When you swipe a card and a door unlocks, it looks simple. You hit a beep, the lock clicks, and the door opens. But behind that single beep is an entire decision-making system. A reader, a controller, a database, a lock, and a chain of logic that has to work perfectly every time. In this video, I show you exactly how access control actually works, step by step. Every access control system, regardless of the manufacturer, is built around 5 core components: Credential, the reader, controller, locking hardware, management software. If you understand these 5 elements, you understand about 80% of how access control system operates. Everything else, networking, integrations, cloud services, builds on top of this foundation. The process begins with the credential. A credential can take several forms: RFID card, key fob, mobile credential, PIN code, biometric identifier. Regardless of the format, the credential contains an identifier. Sometimes this is a simple number, other times it might include encrypted authentication data. Important concept: the credential does not lock the door by itself, and the reader does not make the decision. It only reads the data. When a card is presented, the reader powers the credential using radio frequency energy. Most systems operate in 2 common ranges: 125 kHz, traditional proximity cards, 13.56 MHz, a smart card technology. The reader energizes the card, reads its identifier, and extracts the credential data. The reader then sends that data to the controller. The reader is not the brain, it is simply an input device, similar to a keyboard entering data into the computer. The controller is where the actual decision happens. This device receives the credential data from the reader, then evaluates several conditions. Is the credential valid? Is the user allowed at this door? Is the access attempt within the allowed schedule? After evaluating these rules, the controller makes a decision: grant access or deny access. If the access is granted, the controller activates an output relay. The relay output from the controller controls the locking hardware. Common locking devices include electric strike locks, magnetic locks, motorized locks. When the controller activates the relay, the lock changes state. The door unlocks. The mechanical hardware responds to an electrical signal generated by the controller. In larger systems, controllers communicate with a management server. This server typically handles user databases, access permissions, it records event logs, system configuration, scheduling. Most controllers can continue operating even if the server goes offline. They store essential access rules locally. This design ensures those continue functioning during network interruptions. Let's recap the full process: a credential, reader, controller, decision, relay, lock, event log. When you understand this flow, you understand the core logic behind almost every access control system. Many people assume the reader decides access. It doesn't. The reader only collects the credential data. Others believe the server must always be online for doors to function. That's not always true. The real decision logic typically lives inside the controller. A misunderstanding where that logic resides leads to many design and installation mistakes. Today, most access control systems are networked. Controllers often communicate using IP network, remote management software, centralized databases, cloud platforms. This connectivity makes management easier, but they also introduce cybersecurity considerations. We'll explore those topics in a future modules. If you don't understand the decision flow of an access control system, you can't design securely. Later in this course, we'll discuss topics such as communication protocols, network segmentation, authentication security, defensive system design. But everything starts with an understanding how the system actually works. Access control is no magic. It's logic, wiring, communication, and decision making.